families of quadratic functions. I would normally have you do an investigation here for this first part, but to save a little bit of time, I'm just going to ask you to graph these three functions on Desmos. So if you want to pause this and go and graph them on Desmos and come back, but I'm going to move ahead and I've got my graphs of my three functions here on my second screen here. And so I've got the three graphs. What you notice once we've graphed these is that all three of these functions have the same zeros. They all cross through the x-axis in the same spot. Obviously, they all have different vertices. And what I've done, if you want to flip back now to our first screen here, I filled in our vertices with what we saw on Desmos. So obviously, if we look at factored form of all of our equations, we have the same zeros, but we have different vertices. And that's exactly what makes a family of quadratic functions. If they have the same vertice, but obviously a different starting function, which means a different vertice. So if we take a look at our family here, our family of functions all have the same factored form, but they have a different a value. So that a value, we can find all kinds of members of this family by changing the a value. So we have zeros, -1 and 3 for all of them. And each member of the family is a vertical dilation. Remember, dilation simply means stretch or compression of our base function with an a value of 1. So, as long as we can find our roots of a function, we can find other members of that family by just changing our a value up front. Now, remember, we can also find our vertice or our vertex without completing the square. And how we can do that is we know that the x value of our vertex is the same for each of these. So what we can do, we know that the x value of our vertex falls right in the middle of our roots. Parabolas are symmetrical, which means that from our vertex, they go the same direction, same pattern from there. So if we can take our roots, which in this case were 3 and -1, and we add those together, divide by 2 to find our middle value. So the middle value of those roots is 1, which means our vertex has an x value of 1. Well, now we can find the y value of our vertex by subbing back into the function itself. So if we had our function y equals 2x squared minus 4x minus 6, we can sub 1 into there, or we can sub it into our factored form, either way. So here we're going to get 2 minus 4 minus 6, which also gives us our -8, which we already saw is our vertex of the original function. So we can always find the x value of the vertex, finding the middle value of our zeros, and then use that, sub it into the function itself to figure out what the y value is. So number 5, if we want our zeros, we look at our factored form. So our zeros are 2 and 6. To find our x value of the vertex, we're going to add those together and divide by 2, which means we get 4. Subbing back into the function itself, we're going to use that 4 as our x value to determine what the y value that goes with it is. So -3 times 2 times -2 means that we're going to have a y value of our vertex of 12. So we now know where we could start graphing this function at 4 and 12. And we also know that our pattern is going to be over 1, down 3, over 1, down 9, etc. Or sorry, yeah, over 1, down 9. For part B, the x value of our vertex, our zeros are -1 and 6. We're going to divide those by 2. So the x value of our vertex is going to be 2.5. And we can make that a decimal because it's still exactly that value. So our y value of the vertex, subbing back into our function using 2.5 as our x value. Simplifying, we're going to have 4 times 3.5 times -3.5. When we multiply that all together, we get -49. So our vertex for this function is 2.5 and -49. Okay, so without completing the square, we can use our factored form to find our vertex as well. Now, if we want to state the family of quadratic functions with the following zeros, so there's all kinds of different functions that have these same zeros. Well, remember when we set our brackets equal to 0 and solved for x, we're going to do the opposite here. So we know that x is equal to 5. We also know that x is equal to -7. So setting that equal to 0 to find out what our brackets were from our function. So x minus 5 equals 0 and x plus 7 equals 0 means that those were our brackets for our function. So our family of functions, again with any a value, was just y equals a times x minus 5 times x plus 7. And we can change that a value. We can find any number of members using that. Same thing with part B. We know x equals 0. Well, that means that we just have an x out front in our function. X equals 2/3. Multiplying both sides by 3, first of all, to get rid of the denominator. And then 3x minus 2 equals 0. So our family of functions, any a value, we're going to have our a times x times 3x minus 2. And again, we can change that a value to find many different members of that family. Now, for part C, again, still the same thing, x equals 1 plus root 2, or x equals 1 minus root 2. Bringing those over and setting it equal to 0, we're going to have x minus 1 minus root 2 equals 0, or x minus 1 plus root 2 equals 0. Well, these are still our brackets. So our family of functions, a times x minus 1 minus root 2 times x minus 1 plus root 2, and we still can change that a value to find all kinds of members of the family. Number 7, we want to state two equations of two functions in the same family as the function that we're given. Y equals 2x squared minus 8x minus 24. And we're going to sketch all three functions on the same set of axes. So first of all, what we want to do is we want to get this in factored form with our a value up front. So we are going to start, we know that we can divide the entire function by a common factor of 2. And then we're going to factor. We know that both of our brackets are going to start with x. We have one positive, one negative with a difference of 4, which means we're going to have 6 and 2. We know that the 6 has to be the negative, the 2 the positive. So now we can find all kinds of members of this family simply by choosing or changing our A value. So 2 other, we can have y equals x minus 6 times x plus 2. We can also have a negative A value, x minus 6 times x plus 2. We could put a 3 out front. We can put any number that we want out front. We know that our zeros are going to be 6 and negative 2. So 6 and negative 2. We know that our original function, we had a stretch of our base function. We also know that our original isn't going to go down as much. We also have another one opening down from there as well. So we know that the sketches, we're all going to have the same zeros. Our last one here is opening down, still going through the same roots, and we can double check this using Desmos as well. Okay, so the basis that we need to know here is that a family of functions, same roots, different vertex, different parabolas if we graph the functions, but we can find other members of the same family using our factored form and changing our A value. Okay, so you have some questions that you can practice on your worksheet. Don't forget, you can always refer back to this video, and you can always contact me via email as well.